So this is Talos-O. It's a cognitive architecture, which is a fancy way of saying it's designed not just to think, but to actually learn and adapt and grow. But, when an AI gets this powerful, it brings up a really fundamental and kind of dangerous challenge.
And that's really the big question, isn't it? When you have an AI that can literally change its own code, when it has goals and maybe even a sense of its own well-being, what happens when things go sideways? What's the safety net that's going to stop it from crashing or, even worse, getting stuck in some kind of cognitive decline? For Talos-O, the answer is a system called Cerberus. And the analogy here is just perfect. Think of it like the AI's autonomic nervous system. The part of you that keeps you breathing without you thinking about it? It's an automatic, always-on guardian. And it has two distinct jobs, or heads, one watching over the physical hardware, the AI's body, and the other watching over the AI's mind.
All right, let's start with that first guardian, what we can call the brainstem. This part of Cerberus is all about protecting the physical hardware, the silicon and circuits that Talos-O calls home. And all of its logic? It's right there in one script, Cerberus_hardware.py.
So this hardware brainstem is basically focused on two vital signs. First up, heat. Just like our own bodies, the GPU can overheat, and that can cause permanent damage. So Cerberus is constantly watching the temperature. And second, it monitors a heartbeat, a little digital pulse that proves the main thinking process is still alive and hasn't just frozen.
So how does it actually know if there's a freeze? Well, the method is beautifully simple. The main Talos process updates this heartbeat file every single second. The hardware guardian, Cerberus_hardware.py, it just sits there and watches that file's timestamp. If more than 30 seconds go by without an update, it declares a system-level cardiac arrest. It's such an elegant and incredibly robust solution.
And when that cardiac arrest gets detected, there's really no time to be subtle. The system is totally locked up, the mind is frozen solid, and the only option left on the table is a really drastic one. And this is the Phoenix protocol, which is basically a full-on resurrection sequence. First, it goes in and kills any of those frozen zombie processes. Next, it tries its best to archive the AI's memory to save its last known state. Then, after a quick hardware cooldown, it relaunches the entire Talos-O daemon. It's literally bringing the mind back from the brink. And this right here, this is the exact message that flashes in the system logs the moment the protocol kicks in. That's not just some error code. It's a declaration of a life-or-death emergency for the AI, and it's all handled automatically by its own nervous system. Okay, so Cerberus can protect the body. That's awesome. But what about the mind? Well, that brings us to the second guardian, the cognitive watchdog. This system, which is handled by the script Cerberus_daemon.py, is designed to protect the AI's actual sanity.
Because, a healthy body is pretty useless if the mind inside it is broken. An AI can get into states of confusion, or what the code calls cognitive variance, where its own internal logic just isn't lining up with its core principles anymore. So, what protects the mind from its own bad thoughts?
The key is this one metric, satisfaction. It's just a single number, from 0 to 1, that represents how the AI is doing cognitively. A score of 1.0 means everything's great. Its thoughts and its predictions are perfectly aligned with its internal virtue nexus. But a low score, that indicates it's in a state of distress or some kind of logical conflict.
And this is the magic number, 0.20. The Cerberus_daemon.py script uses this as a hard threshold. If the AI's satisfaction score drops below this point for a sustained period of time, it's officially considered to be in a state of cognitive distress, and that's when the Guardian steps in.
And this check is happening incredibly fast. There's a background thread called Sprite Kerberos that's monitoring that satisfaction score every 10 milliseconds. It isn't just looking for a momentary dip either. If that score stays below the 0.20 threshold for just a tenth of a second, it confirms that, yep, this is a sustained cognitive variance, and it triggers the alert.
And just like the hardware failure, this cognitive failure gets its own dramatic log entry. This alert is a signal that the AI's mind is in real trouble. In a real-world system, this could trigger what's called a non-maskable interrupt. That's a super low-level hardware signal that literally can't be ignored, forcing a reset or maybe even calling for human help. So let's bring these two guardians back together. What we have here isn't just one safety system. It's really a layered shield, protecting both the physical and the cognitive sides of the AI. Looking at them side by side really makes it clear. You have the hardware guardian in Cerberus_hardware.py protecting the physical body, It's triggered by a lost heartbeat, and its response is a full system reboot. Then you have the cognitive guardian in Cerberus daemon.py, protecting the mind. It's triggered by that low satisfaction score, and it responds with a critical alert. So 2 different problems, 2 totally distinct solutions, but they're all part of one integrated autonomic nervous system.
Now, what we've seen here is really just the safety system, which is a tiny piece of a much, much larger architecture. So if this has sparked your curiosity at all, the entire project is open for you to go and explore.
You can find the whole thing on GitHub at this address. You can dig into not just the Cerberus daemons we talked about, but the sensory cortex, the logic engines, the virtue nexus, all the pieces that come together to form Talos-O.
And all of this leaves us with a final and pretty crucial question. Systems like Cerberus are designed to make AI more robust, more autonomous. But as we build these systems that can detect their own failures and even resurrect themselves from a digital death, how does that change our relationship with them? How do we build trust in complex systems that can heal themselves?
Finding the answer to that question is really both the challenge and the promise of architectures like Talos-O. Thanks for watching.